Okay, so we're back at chapter 3, and we're talking about quantitative data. We've learned how to create displays that are histogram, stem and leaf, box plots, and dot plots. Now what we're going to do is we're going to learn how we describe them or summarize them. Okay, so the first thing we need to know is what a mode is. Mode is kind of frequency. It's not mode like you think, like the most numbers. A mode is, for our stats level, is how many humps you see. Okay? Unimodal has one hump. And so it's going to look something like this. You're just going to have one hump. Okay, and so a bimodal is like bicycle, 2, so this has 2 humps. Now, one thing I do want to make sure you understand is that humps are kind of far apart. So that could be considered bimodal. If I'm going to draw an example, a non-example of bimodal, you could put it somewhere if you want, or you could just watch and see. So let's say I do this, but then I pop back up here. This is not enough space. That's not enough space to make it bimodal. Bimodal, you need to have a big enough space apart so that you can see it's 2 distinct humps. So this is not enough space for bimodal. I would still consider this one unimodal right here. This is still unimodal. So you remember, you have to have a big enough gap or big enough space in between the humps. Multimodal is 3 or more. Same rules apply. There has to be a big enough gap in between. I'm not going to draw this. I think you guys would understand what that is. Uniform. Uniform, a lot of times people get confused with one hump, unimodal, because it's uni. But uniform is just no humps. And so everything's kind of the same height. Maybe a little bit taller or shorter, but it's no distinct humps. Okay. And we should highlight those because those are all vocabulary word you got to know. Oops. Okay, now there's other ways that you have to describe quantitative data. Let's see. So the first way you describe it is symmetric. And when something is symmetric, you're going to think about it as a line of symmetry. And so you're never going to say something is exactly symmetric. You're always going to say something's roughly or approximately. Stats is always a little off, and so you never want to say something is perfect or exact. So we throw in the word roughly, approximately. That kind of helps. Tails. Tails are the way that it trails off, okay? And so a tail is kind of like a train on a dress, like a wedding dress. They have long trains, and so that's where the tail is. And so a tail is when it's thinner at end in one direction. So this one right here, you see how it gets thinner right there? That would be a tail. Okay. The last one we have for this one topic, we'll talk about outliers and gaps in a second, but the last one we have is skewed, and skewed is the direction of the tail. A lot of people are going to get this backwards. You have to be careful of this. Whatever way the tail goes, that's the direction of skewed. So this tail is on the right. So this graph right here, this picture for the unimodal is skewed to the right. Okay? So skewed is the direction of the tail. So if I have, so this is skewed right because the tail is right here. And this one is skewed left because the tail is right here. Okay. One thing that is important, let's pick up color purple. These three things deal with something called shape, and we'll talk about that in a second. But these three things you have to talk about when you talk about the shape. All right, the next two terms we have is an outlier. And an outlier is something that just doesn't fit. And it's always to the left or right. And we learned how to find outliers on box plots because outliers were outside of the fences. But for histograms, you won't always see them. You're going to kind of say there's a possible outlier. Gaps is when there's nothing in bins. Hold on. Okay, so a gap is when nothing is in the bin. So if you have something and then I don't have anything till here, this is a gap, right? That's a gap, and we'll have to talk about the gaps. That's a possible outlier. Okay. All right, so now when we describe histograms, box plot, and stem and leaf, describing what you see is actually the biggest part in stats. And so we have kind of a, what is it called, an acronym? We're going to describe things using SOCs. Okay, S, oh, wrong end of the pencil. S stands for the shape. And when we talk about the shape, the things you have to talk about are the humps. So you're going to say whether it's bimodal, unimodal, multimodal, or uniform. You also need to talk about whether it's symmetric or skewed. When you talk about it being skewed, you have to say which direction. So if you have a tail to the right, you're going to say skewed to the right. If you have a tail to the left, you're going to say skewed to the left. You do not say anything about the tails. The tails just help you say which way they're skewed. I think I didn't say tails again. Yeah, hopefully I didn't confuse you. Okay, so the O stands for outliers. And for this one, you're going to talk about possible outliers and gaps. On a box plot, you can say there's definite outliers. On a histogram, you're going to say possible outliers. Okay. Center, C stands for center. Now there's two centers. There is the mean or there is the median. Okay, and I put a lot of space here because you will use the mean if it's symmetric. Oh, look at that. Not good planning. I did not do good planning there. Sorry about that. So you'll do the mean if it's symmetric or the median if it's skewed. So you have to look at it and recognize, okay, if it's symmetric, I'm going to say something about the mean. If it's skewed, I'm going to say something about the median. The other thing we need to talk about is the spread. And spread kind of talks about how far apart things are, like how spread out is the graph. So if it is symmetric, you're going to use something called the standard deviation, which we will go into in our next video. If it's skewed, you're going to use the median. Not the median, I'm sorry. If it's skewed, you're going to use the IQR. Okay? So we have to make sure that we talk about shape, outliers, center, spread. There is one thing that I want to talk about with shape. On box plots, you cannot see humps. You can definitely see whether it's symmetric or skewed and outliers, but you cannot see humps on box plots. Okay. Now, the most important thing about when we're doing these descriptions is actually saying things in context. If you leave off context, you're losing 2 or 3 points out of 6 or 7. Like, you have to have context. Context is super important, okay? So what we're going to do now is we're going to go back and look at some of the graphs we had before. And this is where I had talked about you guys having stickies, and we're going to put kind of a makeshift sticky on top of the graph so that you can see the description. Okay, so we're up to our first histogram. So remember, we're going to talk about, oh, look at this. I love this marker. You guys are going to like this. We're going to talk about socks. It changes colors as I write. Isn't that cool? Okay, I won't do that because that'll be distracting, but I do like that marker. Okay, so let's do this. So we're talking about the frequency of states visited. So we start off, we don't say the histogram, right? We always start off with the distribution of number of states visited is, and now I go into context. So if you start your sentence off with the distribution of whatever you're talking about, you're going to get your context. Okay, so I'm going to say that this is unimodal. I have one hump here, is unimodal. And I would say this is skewed to the right. This is a tail. This makes it a tail, right? Because it's out here and skewed to the right with a gap, because now I'm talking about my outliers and gaps, with a gap between 30 and 50, not gaps. Got to write small for sticky notes, and I can't write small on this. Between 30 to 50 and possible outlier. And again, because I don't know for sure on histogram. I know for sure on box plots, but not histogram. Possible outlier at 50 to 60. Okay? So, because I am using the word skewed, I need to say where the median is. Okay? Determining where the median and mean is a little tricky right now. We will definitely get into more concrete ways. But essentially what happens, there's one person in this box. I think there was 3 in this one, 9 in this one, and 15 in this one, right? And so that's a total of, what is that, 28 people? So the median is where the 14th person is. So the 14th person is in here somewhere. That's where the median is. And so now, with, let's say, and you don't have to say center. You can actually use the word median. If you use the word mean, though, I'd have to take off a point or two. The median is about, because I don't know exactly, like when we start using our calculators, you'll know exactly. I'm going to say it's about, it's probably in here somewhere. So I'm comfortable saying 15, or you could say is between 10 and 20. When we actually start using our calculator for calculations, then you're going to have to find it, but for right now, this is okay. And the IQR is about, okay, so let's look at IQR. So IQR is where it's half of the median. So IQR 3, or Q1 is at 7. And then Q3 is the 21st thing because it's half of 14. And so I add 7 and subtract 7 to find out where it's at. So quarter 1 is in this box somewhere. And I would get from 9 to 15, 24. Quarter 3 is in this box somewhere, because 21 is in between 9. It's 9 plus 15 gives me 24. So quarter 3 is in there somewhere. And so I would say the IQR, this is where it is kind of tricky. IQR you're going to subtract. So we're going to say that it's maybe 19 minus 8. So it's about 11. So we are definitely going to do more of these in class. And it'll be more, it'll become more clear. But here's one example. And this was a hard example because I couldn't exactly see where my median or my IQR was, but they will get easier. Okay, so make sure you understand SOX and how to describe it. And those are the first steps in being able to describe any kind of quantitative data.